The universe threw the biggest party in history 13.8 billion years ago, and somehow antimatter didn't get the memo. Picture this. Matter and antimatter were supposed to be equal guests at the cosmic celebration, but when the lights came on, antimatter had mysteriously vanished, leaving matter to rule the entire universe. This isn't just a funny cosmic mix-up. It's one of the most mind-bending mysteries in physics that could rewrite everything we know about existence itself. Welcome to the ultimate cosmic detective story, where we're hunting for the universe's missing half. I'm about to take you on a journey through the most exclusive party ever thrown, where the guest list went horribly wrong and the consequences shaped literally everything you see around you. By the end of this video, you'll understand why this cosmic no-show might be the reason you're even alive to watch this right now. Let's start with the basics, because this story is stranger than any science fiction. Matter is everything you can touch, see, and interact with. Your phone, your coffee, your pet, the stars, planets, and galaxies. It's made of particles with positive and negative charges that somehow learn to play nice together. But here's where things get weird. For every particle of matter, there should be an identical twin called an antiparticle. These aren't just theoretical concepts. We've actually created antimatter in labs, and when matter meets antimatter, they annihilate each other in a burst of pure energy. Think about that for a second. Every proton should have an antiproton twin. Every electron should have a positron partner, and when they meet, they destroy each other completely, converting all their mass into energy. Einstein's famous equation E equals mc squared isn't just theory here. It's a cosmic demolition show where the tiniest amounts of matter can release incredible amounts of energy. Now here's the cosmic comedy. According to our best theories, the Big Bang should have created equal amounts of matter and antimatter. Imagine a perfectly balanced cosmic recipe where for every ingredient you add an equal amount of its opposite. The universe should have been born as the ultimate stalemate, with matter and antimatter particles constantly finding each other and annihilating in spectacular light shows until absolutely nothing remained except a cold, empty space filled with photons. But obviously that didn't happen. You're here, I'm here, stars are shining, planets are spinning, and galaxies are dancing across the cosmos. Something went catastrophically right in the universe's first moments, and antimatter apparently missed the biggest party in history. The plot thickens when we realize just how precise this cosmic party crash had to be. We're not talking about a small imbalance here. For every billion particles of antimatter, there were apparently 1,000,000,001 particles of matter. That tiny difference, just one extra matter particle for every billion pairs, is literally the reason everything exists. Your morning coffee, your favorite song, your childhood memories, the light from distant stars, and every single atom in your body exists because of this minuscule cosmic accounting error. Let me paint you a picture of what this cosmic party looked like in the universe's first second. Imagine a dance floor packed with matter and antimatter particles, each desperately seeking their opposite partner. As they meet, they explode in brilliant flashes of light, disappearing forever. The cosmic DJ is playing the most intense music ever, as billions upon billions of these annihilation events happen every microsecond. The energy is so intense that new particles are constantly being created and destroyed in an endless cosmic rave. But then something remarkable happens. As the universe expands and cools down, the party starts winding down. The music gets slower, the energy drops, and suddenly there's not enough power to keep creating new particles. The cosmic dance floor clears, and when the lights come on, there's this tiny handful of matter particles standing around looking confused, wondering where everybody went. Scientists call this the baryon asymmetry problem, and it's been keeping physicists awake at night for decades. We know it happened, but we can't figure out exactly why. It's like having security footage of a bank robbery, but the cameras somehow missed the actual crime. Here's where the detective work gets really interesting. We've got several suspects in this cosmic mystery. The first suspect is CP violation, a fancy way of saying that the laws of physics might not be perfectly symmetric. In the 1960s, scientists discovered that certain particles behave slightly differently than their antiparticles under specific conditions. It's like finding out that left and right aren't perfectly equal in the universe's fundamental rulebook. Another suspect is something called electroweak baryogenesis, which suggests that during the universe's first fraction of a second, there was a phase transition that slightly favored matter over antimatter. Think of it like a cosmic coin flip that was just slightly weighted toward one side. Then there's the mysterious world of neutrinos, those ghostly particles that barely interact with anything. Some scientists think heavy neutrinos in the early universe might have decayed in a way that produced more matter than antimatter. It's like having invisible party guests who left behind evidence of their presence. The most mind-bending possibility involves the Higgs field, that cosmic background that gives particles their mass. Maybe in the universe's first moments, the Higgs field went through a phase transition that created the perfect conditions for matter to slightly outcompete antimatter. But here's what makes this mystery even more fascinating. Antimatter didn't completely disappear. We can still find tiny amounts of it being created by cosmic rays hitting our atmosphere, and we've even learned to make it in particle accelerators. The European Space Station has detectors specifically hunting for antimatter signatures that might tell us where the missing antimatter went. Every time we create antimatter in a lab, we're essentially recreating the conditions of that cosmic party from 13.8 billion years ago. We can watch matter and antimatter annihilate each other, releasing the exact same type of energy that lit up the early universe. It's like having a time machine that lets us peek back at the universe's most important moment. The cosmic implications of this mystery are staggering. If we could solve the antimatter puzzle, we might unlock the secrets of why anything exists at all. We might discover new physics that could revolutionize our understanding of reality itself. We might even find ways to harness antimatter as the ultimate energy source. After all, matter-antimatter annihilation is the most efficient energy conversion process in the universe. So the next time you look up at the night sky, remember that every star, every planet, and every galaxy exists because antimatter failed to show up to the universe's first party. The cosmic guest list went wrong in the most spectacular way possible, and that mistake created everything beautiful and complex in our universe. The universe's first party crashers turned out to be the ultimate no-shows, and their absence gave us the greatest gift imaginable: existence itself. Sometimes the best parties are the ones where the right people don't show up. Thank you for watching this video, and see you soon for new adventures.